All right, we are going. Welcome everybody. Day 13, and let's see if we can actually get a callback proper going today. After I took a long tangent off to go into some OM2 and stuff like that. Now, if you're watching these on YouTube, there might be a pause in the video, or there might be a short period where you only see my chair. My daughter is sleeping, has been sleeping for an unusually long time, so there might be wailing anytime in the next 10, 15, 30, 60 minutes, and at that point I'll have to take a 5 minutes break. And if you're on the stream, just know that I'll just turn on the mic, go and do whatever I need to do, and then come back to it. But we are doing this. Nothing will stop us. So, now, I haven't touched these in 8 days. We'll see how that goes. The last time, what we got to was basically a bunch of OM2 stuff to explain how to extract matrix data from things, how to find plugs. I think we had done that before. A little bit of discussion in those regards. Now, what we did not do basically is actually install a callback. But we do have an example of that here, I believe. And let's see, let's make sure that we have what we want. So day 12, which is where we're left, which is an ether selection, matrix from mob, that's cool. And I might need to open another one up to make sure that I also have at hand our notes for the actual callbacks. I just don't want to do things differently every time and confuse people, so have a looky at that. And do I get drag and drop here? Yes. All right. This is another thing I like about charcoal that Maya just doesn't do in the script editor. I don't know why. You can actually reorder tabs. All right, let's start with this. So we have the stuff we did for the callbacks before, which is showing how to install one. And that's largely like just having a function that implements the signature of the callback that we want to use, and eventually passing a payload, the plugs that it's going to affect if you're implementing a type that is supposed to get plugs, catching the message and all of that. We did show how to, and this is the commented version that I actually put up on the website, that shows how to get the word matrix or something, how to extract the matrix, which is, a little bit of my specific crud in this case. This is the part that I had before, the uncommented one, I believe. Yep. So these should actually run for a selection of 2, and it should get us, yeah, this is the one where we got a matrix and a rotate by. So we're gonna first implement it as a script. We want to get the match between IK and FK running as a standalone script, and if that works out, then we're gonna implement it as a callback proper. Now, these should be a good enough starting point, so let's go with that. Now, if you don't know it, sorry, if you don't know it, you can actually, if you're in an IDE, there's, instead of importing OpenMaya, you can actually import OpenMaya Pi2 with an underscore. That's just stubs. In IDEs, these will often get you auto-completion, whereas the plain OpenMaya won't, but they're pretty much equivalent. So, what we are gonna do next, and the last time I think we got to the point where we were getting the right data but not switching right. We had done things in a very cursory fashion. What we want to do from these, we said we're gonna have our settings just to have a, just to have a place where we can actually affect the attribute, install the callback, and in that same place, without having to jump around, also be able to retrieve what we care about. We say we will get the rotation itself, the angle, from the blend node, which should actually get us an angular rotation here, which is the blend is the one that's going to get us the FK1 or the IK1. So this is pre-switched. We could also choose to actually get the input of this. Now, if I turn that to 1, so let me close that for a sec. It should also get me all the sources. So if you, that's the output. We don't care for that. That's the input. We do care for that. Don't care about the weights in this case. We could actually also look up, depending on how we go about it, we'll see if we need to switch it. We could actually also look up the separate ones for the, this is pedals and buffered, so these will be for the FK, and this is for the FK. So if we want to switch from one to the other, and our pre-switch one is not in the state where we want it to be, then we might need to find these two. It depends on when the callback fires. So one note on that is when callbacks fire, if it fires on something like attribute changed, it might be before or after. In this case, I think it's actually before things have been dirtied and recomputed. Sometimes that plays in your favor, sometimes it doesn't. You can use mixes of callbacks to find if something has changed. But the long story short is, when I change these, if I were to install a callback in that to monitor the attribute change, me changing it, going from on to off, might fire off the callback before the actual graph has been dirtied. So before these values actually change. Now, if that's the case, and we'll need to look at it, that will be convenient because it means that we will change it, get the value as it was, and then apply that value to the next space. Or if it's gonna actually fire up and get me the value after it's been changed, probably not going to be good enough. In that case, we're going to look up multiple values. Now, the other thing we say we will do, we could actually even just look up at that node and look at the sources from that, but we won't do it just yet. Now, we also say that we want the buffers because we want to find what space we need to change that that actual translation to. And one thing that I was not doing, just didn't get to it, is for the FK, all we care about is the rotation, because to get it working, the IK will produce a rotation. Now, if I apply that rotation to this item, that's good. That's pretty much the switch, you know, it's going to go this way. It's pretty much the switch done. But if I wanted to switch the IK to the FK, then it's a little bit trickier because I actually need to position these here, which means there's actually a positional offset that we need to take into account. So we need one more thing, which is the distance between this transform, like the one that we actually have the rotation working in, and where we want the offset to the IK to be, and then we multiply, usual thing, and that places our IK where we need it. Hopefully that makes sense. Now, we did set ourselves up for success in those regards, because we did have we say we would have had the inputs with those offsets somewhere as a guide kind of thing. So those are going to come in handy. Now, we do have one, and this is our guide. We do have the local word here, we have the stuff here, and then we have the pedal offset, which is going to be static. So it's where the default offset between the IK and the center of the staves is. That's what we want. So if we get the local translation for that, if we get the local transfer for that, that's gonna tell us how we want to actually offset things. If we cared for just the position of it, which will not rotate our IK the way we want it potentially, then we'll just get the translation. If we also wanted the IK rotated, then we'll get the, which is irrelevant for these. We're not doing anything with the rotational input of these. Then we will get the full matrix and do the composition. So let us get that. Now, normally not a huge fan of mail or commands, but there's some stuff where it just comes in handy. And if you're unfamiliar with it, when you add an attribute to something, you have a fairly limited choice if you use the default interface, which is just vector, integer, string, float, boolean, enum, and that's it. But if you actually use add attribute, add attr as a Python command or as a mail command, you actually have a ton more types of attribute, which is how we've been doing the messages in so far. I don't think that needs elaborating on any further. So what we want to do is get ourselves the offset, and that is going to be add after -80 for the type. Is that a string? I think it's a string. The text for that is gonna be minuscule. Let me do it in an actual script editor, otherwise nobody's gonna be able to know what I'm doing. It's okay, that should be slightly more readable. So I don't remember if the type should be a string or not. Then you have long name and short name, and long name for that will be, let's say, IK buffer offset, IK pedal offset. Yeah, sure. So will that work? Yeah, seems to work fine. So they're both strings for the type of attribute as well. The name, it's obviously enough a string. That gets us another object here. That is where we want to get these. So control, cool. Remember that we're just interested in looking up the objects themselves to be able to retrieve them. So we connect messages. They have no effect on the actual evaluation. Chat as usual. If you have any questions, if you think that we need to clarify something, I am relying on you. Now, with that out of the way, sure, I don't want to save it. We want to move on and find a bunch of things. So we have an iterate selection. Let's say that we are actually working always on the first object here. So tuple iterate selection, we don't need this filter anymore. This is going to run our script. So we need to set these up so that we look up everything as we want. Now, so if mob tuple, which means if it has a length of any kind, then what we want to do is first find the two buffers, I reckon. Well, first we want to find the attribute for the switch. So let's get that onto MFN dependency node, and we should be able to do mob tuple 0. Do we trust that to be the settings? Yeah, for now we will. We could put a check in here to make sure that we have the right selection. So you could check by name, or you could check for the existence of the attribute. We are doing that here, so we are going to recycle that. And we're going to go has attribute. We know that we call that one FKIK switch. Remember that the names that you see in here or in the attribute in the attribute editor you often get the actual real name of something, but the names that you see here are often the nice names, which means they are oftentimes not the real name of the attribute when you actually need to look for it by string. So to verify what something is called, what the right capitalization, because Maya will choose to capitalize things for you. So if you use lower camel case with short acronyms and stuff like that, you will often get not quite what you want. So let's undo that. All I wanted from that was a log, and that log will tell me what the real name is, which is fully capitalized like that. So we use that. Now if once we have that, we can go, if that is true, then we want to find the value of it, which is going to be mfn dep equals that, mfn dep, actually let's get an empty plug. So there's two ways you can go about this one for the record. You could do plug equals none and go Pythonic. So after you fetch something, you could go if plug is not none, then you do something. The other thing you could do is you could go and do mplug, and in C++ you would be doing these a lot more because you can change the type of things at will. So, and then the check you will run, and this is going to create the plug, and that plug is going to be a null plug. Now let's look up the docker for a sec just to make sure that we're not saying anything stupid. The verification for that is actually going to be is null. So this is my wife asking if she can make any noise. Of course you can. She was asking if she can make coffee. I love this woman. Yes, you can make coffee. And you can use the microwave. So you're gonna hear Italian coffee making as well as a microwave. That is the nature of a live stream. And amazingly enough, our daughter hasn't woken up yet. This has been a lot longer than she usually sleeps for at this time. So what I want to do is get the Docker for the unplug. Now there should be a method. Oh man, this is awfully small. Okay, this is too much. Cool, this will do. So there should be is null, I think it is, or is valid. I don't remember. Like, you'll find those interchangeable. Yeah, is null. In C++, this is usually a method. Like all of these things are methods. This is where you want to look at both documentations. And you'll see that in this case for the Python API, it's no parentheses. It means it's an actual attribute. So don't put parentheses in there when you call it. So we're gonna do that, and we're gonna do find plug, and we're gonna use the same name. You could make this into a constant. You could have yourself a dictionary. Doesn't really matter all that much. So in that case, we're gonna do that, and we can go. So if not plug dot is null, remember it's an attribute, then we can do something. Otherwise, you know, something like that. So that just validates our selection. If I was to run something like that, let's see if it actually works. If I was to run something like that, oh yeah, I forgot. There's another argument to find plug, which is whether you want the network plugged or not. So if I was to run something like that, then it tells you, okay, there's an FKIK switch. Now, if I was to run it on another object, it should actually tell me whatever, whatever the message I put in there is. So I'm gonna start writing Python that looks more like the usage of the C++ API than this. Than the canonic, idiomatic Python you will see. And I think that's one of the things I like about OM2. It's a good gateway drug to the actual use of the C++ API. So if it's not null, then we know that we have valid plug. We want to get the value. Now this is the part where C++ and Python will differ. In C++, function overloading, you would just get the value of the plug and you will be cool, and you could set it, and it will assume what it needs to use method-wise from the type of the value you're passing. Python is not strongly typed, so if you want the value, you have to do, you have to get it exactly as the type that you expect. We know it's a bool, so let's comment this out. And wrong selection. Yeah, I might actually want to print that value. So okay, it's telling me it's false. Now let's just make sure that we're getting everything right. Now it's telling me it's true, so we're good. Now, next thing that we want to do in there, chat is still quiet, so hopefully it still makes sense. If not plug is null, we could probably make this into a function so that we could use early returns instead of indenting the hell out of it, but not yet. Don't do things you don't strictly need to do before you need them. Generally work well for code. Now, if all of this is true, it means that we are with the right node. And if we are with the right node, what we want to get is a bunch of values. So let us also build a dictionary of things that we're interested in, I guess. And that's gonna be, for now, let's use a silly name. That's gonna be a dictionary, and don't need an empty one actually. I could right away use the right names. Will I have the right names? So we have blended rotation. I'm gonna, oh, sorry, not ID, so I can just string up something. Then we're gonna go FK buffer matrix. Oh man. See, can you show? I don't think you can show the real names of things easily enough. The attribute editor should be more generous. Possibly not. Yeah, it would have been convenient. So control, yeah. So edit attributes. This should get me the, yeah, this gets me the real values, which is a lot more convenient. Tiny window, I can't do anything about this. Hopefully, well, you don't really need to read it because I will punch the meaning here, but it's what we have to live with. So the other one we're interested in is FK buffer matrix. I wonder if we're actually gonna get to the callback this time around, or if it's gonna be just more programming. We'll see. Then IK pedal offset, and what do we have? IK buffer matrix. For the record, Python wise, it doesn't matter what order you put things in a dictionary. It's one of those types of data that is actually unordered under the hood. So yeah, like put them in whatever order you want them for your convenience of reading and editing. Pedals gravity align, we don't really care. Root to end switch, we don't really care. So this is what we actually care about. Now, if you knew that you were gonna edit, if you were in, you know, fairly rich in functionality IDE, and you knew we were gonna edit things, and you had duplicate line, which I don't. Oh, yeah, it actually does. That's great. So charcoal also has duplicate line, which is brilliant. So if you need to edit a dictionary a lot, just if you format it like this, which is, you know, a little bit of string real estate, but you can just duplicate the line and then edit what you want, and it'll be a valid dictionary. Now, we'll say let's actually satisfy OCD conditions and have them in the right order. Well, as in an order where I know what I'm getting. Now, we do have everything we want in terms of strings. We want to put some values in there. Not gonna go C++ live for these with actual types in there, because they will be overwritten anywhere, and that will be the case in C++ as well if you were using a dictionary-like object. So if not plug is no, that is just our verification for what we're doing. Then what we will be doing is so for each plug name in attributes, and if you iterate like these, it's gonna copy the keys and put them in there. So you might want to use iter keys, and we could actually iter the values. Nah, iterating the values and setting them in place might be dodgy. Then what we want to do is, I think we can actually modify the value in place just fine. So one thing we could do is actually go, this mfndep is going to be set in the right place, as in it's going to have the right object in this case. So we will pass it HP name, and that will get us the plug. And then we could actually go and do, because this is a static edit, and go, we'll modify the dictionary in place, which should be fine in this case, and go plug. Now, yeah, that should be fine. And after all of these, just for validation, let's also see if we correctly modified. Whoop, wrong variable name somewhere. Yeah, wrong capitalization here. So there you go. It's going to tell you there's an mplug object here and here and here and here and so on. Now, something to be wary of is plugs are extremely volatile. So if you do something like this, and you take something like a dictionary and you populate the values with a plug, and if you were to hand it off to some other function somewhere, these items, the way the bindings work is pretty good in terms of performance, but it can leave you with volatile data very easily. So Python might actually decide to garbage collect something upstream, and it will basically make this plug invalid. So it will be passed on, it will be a formed object. So in here, you would actually have a Python object that can be queried through several things, but it will not point to the right plug. If you find yourself in that kind of situation, I don't think we will for this case, then what you will normally do is you will store a couple of object handles, one for the attribute and one for the node, and then you will rebuild your plug from those two. I don't think we'll need it here, so I'm not gonna go any further into that, but yeah, know that you might need it. So I'm wondering if a list would have been better, so that we had ordered Nah, fine. So what we want to get in this case is the various attributes that we're going to use. Actually, I was saying we're just going to use messages, but in reality I know that from these all I care about is the translate attribute, so I'm going to get myself the translate attribute instead. And we're done with those, so we don't care for these, and we can just nest these, and these should still all work fine. And let's confirm. So that's fine, and if I select the wrong object, that's also fine. It's saying that's not cool. Now we leave that loop, and to avoid nesting a million things, no, that's downright wrong actually, because at this point the plug will always be null, so we have to redo this. So to make sure that the dictionary was valid here, so that we don't keep nesting inside this loop, we can check the dictionary, and we can go yeah, anything in the dictionary. So none, not in, attributes dot ether values. So if there is no none in ether values, we know that that dictionary is valid. Now it's telling me false because I have something else selected, and it's still telling me false if I have the right thing selected. Now why is that? So let's have a look. It's not reaching here, so that's the issue. Should really not reuse names like these, but MFN dep is in the right place. The dictionary is correct. Is it reaching here actually? It is not. Oh, of course it's not. I wonder if somebody in chat is actually gonna say, oh, you were doing that wrong. So mplug or mobject expected, that's good. As in that's an error that we can deal with. Plug, find plug, line 70 is valid, equals known, not in, oh, because that's for the comparison. So we'll have to iterate. This valid equals false, actually equals true, and for you can use whatever you want in here. For p in, we were saying attributes dot ether values. If p is none, this should actually work. So actually we can do so and then we break. So we should now, yep, we should now basically go across all the values. So what was happening, just in case that wasn't clear, I was going like if none in, which would run an equality check on all the values in there. And what is basically happening is that that equality check in Pythonic terms will be on the plug object. So it will go plug dot underscore underscore equal underscore underscore none, and it will not support it. The bindings will not support comparing to none. So what you can do, the is check in this case for none is pretty trivial, it's pretty fast. So what we're doing is we're iterating all the values, and if at any point we find that anything in here is none, which is actually something we can do in this case without doing isin, we say, okay, this is not a valid dictionary because one or more of these have not been initialized, but we'll stop at the first, break, and we don't have is valid. So I sort of suspect that we might not get to the callback itself, but hopefully we'll get the script done. Now, there's not a lot else we need to do on this read. So chat, these two all clear, all good to go? Let me know. I'll take silence for everything is clear. Some noise will be good though. Reading something in there, if anybody has any good jokes. So the next thing we want to do is actually get us some values. Now we say that we want the word matrix for the buffers. What about this? Yeah, somebody is being facetious in chat. There's not going to be any unit tests for these. I'm sorry. I'm not really sorry, but no, there's not going to be unit tests. So what we were saying is we actually want the word matrix for the buffer of these, the word matrix for the buffer of these, and the offset will be good as an endpoint probably, and we'll get to that in a moment. And the blend rotation we do care about. So in that case, what we will do is now if is valid, so I really should have put this in a function, it will be less indented, but it's okay. So if is valid, what we want to do is get us, so blended rotation, we care about it, so we'll go blended rotation, we'll use the same names. Okay, buffer matrix, IK buffer matrix, and IK pedal offset, so we match those keys. I think this should actually be valid in Python. Some days I switch between enough languages that I confuse myself. Well, we need something selected. Non-type is non-iterable. Oh yes, because in this case it would actually want a tuple. Fair enough. What we want is a chain of equals in Python. So yeah, these should be valid. Now, what we want to do next is actually get ourselves the values. We're finally getting somewhere. So we could actually have initialized these right away with the values that we wanted, but in that case we will be inside some scope, whereas I'd rather have the expectations of what I expect. Well, I'd rather have what I expect to have as a list of something set to none, and then go over those values so that when I come out of whatever settings I was trying to look for, I know if I found whatever I want, like everything I wanted. Now, blended rotation equals, we did get emerald node from output, so if it has an in blend, that's good. That should get us right away what we want, I believe. So misspelled offset. Did I? Yes, thank you chat. One less error message. So blended raw, get emerald node from output, it means, so in here we're giving it node mob if it has an in blend, so we're looking at the original parameter, plug find plug and so on. Do we care for that much? Probably not, because we should be able to get just the source in this case. So blended rotation equals, we're going to keep that function around, but then we go attributes. If you want to be really forward-looking Pythonic, you should probably do get instead of using square brackets. Not a huge fan of like the Python 3K compatible syntax, to be honest, but there's worse. So that should get us the value. Do I have to remember to save, or does charcoal autosave? I think charcoal autosaves actually, but you make a good point, I reckon. Where do we save this? Thank you. I've had charcoal like coming up after a crash with exactly what I expected to have in there. So I don't know for sure, but I suspect it actually does autosave. But let's not risk it. Let's also save the scene since we change a couple connections. Now, attribute get blended rotation, usual thing. Normally I will probably blaze through a good chunk of these without checking every single step, but doing stuff as we talk about it, it can get a little bit trickier. So this will get me the value, which should be a plug, and that plug should be something that I can get as an M angle. So if I want the blended rotation, I should be able to do as, oh yeah, I have it up there, and then go the next one, which is gonna be fk buffer matrix equal attributes dot get. And that will be a matrix. So that we said is actually going to be a little bit trickier, and we have word matrix for mob. So we will probably repurpose that into a word matrix from attribute, I guess. Yeah, we do want one of those. So let's go that blue matrix. Actually, matrix from plug. We expect to receive a plug in these, and what we will be doing is, so this will be our plug, and then we would expect to receive an array plug, or are we actually? No, I think we're connecting the sub plug, which will spare us from that. Yes, we are. So do not need that part. All we need is get the attribute, get the functor, and then return the matrix itself. So plug as m object gets us the attribute, the data is the matrix data, and not gonna comment these, but it should be it. So in that case, what we want to do is matrix from plug and pass it the plug that is inside these. Let's see, that seems to be working still. Now duplicate that, and we do the same for IK buffer matrix. Copy and paste the code, always a dangerous thing to do. So some schools of thought say you should never duplicate lines or copy and paste code. You should always type it out explicitly. It will save you pain. It's kind of true. If you're doing a lot of these, and if it's stuff that is tough to debug, like this, we will get an immediate failure. It will be pretty obvious what's going wrong at some point. Well, actually, no, it might be insidious, but so I'm not going to bother with it. But if you're writing code where there is some level of ambiguity between things, careful with copy and paste that, because if I had copied that and just forgotten to change this part and only change this part, what I will get is the same matrix in both attributes, in both variables, and then the blend will maybe actually work, but we'll be blending between two identical values, or it will be setting the blend to the wrong parent, and you know, you might spend hours debugging something for the wrong copy and paste. Word of warning, now you know, do as you wish. So next is IK pedal offset. Hey Jordy. I capital offset equals, what were we saying? We're gonna get a translate from that. So that's gonna be a compound plug. Is there, can I get it as an m float vector right away? That's the question. So the way to find out is there as point will probably be what you're looking for here. As a main goal, as in data, as short a string. So there's nothing really to get something as a point or as a vector, which means we'll have to cook our own. So let us do that. We say we wanted an endpoint, and I'll explain why. Endpoint from plug. So node mobatter. So from the plug, we should be able to get the children, and we should be able to get them by name. Trying to think here for a moment. So okay, it's time, documentation time again. So let's actually do a super quick detour here. So what we're dealing with, I don't think I've explained this, so we'll spend a minute doing that. What we're doing here is we have a plug that is the translation of an object. Now that plug in Maya, like when you just add the translation with create point and stuff like that, it might be deceivingly simple to deal with it, and we could just go and get tx, ty, and tz and then make our own vector out of that. But that is a compound plug. A compound plug has n arbitrary plugs underneath. You can take any type of plugs, like put them together in a compound. You can have compounds of compounds, compounds of arrays of compounds. It can get pretty interesting. Now, what happens is that the subplugs are going to be called whatever, and the compound plugs in some ways are very similar to an actual dictionary. So if you had something like an array plug, like we did for the word matrix, then there's a pretty considerable difference, which is the elements under the array are going to be indexed, and they're going to be indexed one of two ways. Well, they're going to be indexed both ways. You have logical indexing and you have physical indexing. We're not going to get into that. But what happens is that with the array, if you iterate the array in logical order, you are going to get plugs in the order you expect. Now, the fact that child plugs in a compound are actually more similar to a dictionary is kind of tricky. If it's something very simple like XYZ, you could almost rely on the order being correct, but the reality is a dictionary is not ordered. A dictionary is usually has a table, usually a hash table with some sort of indexing, and then it has some values, but that hash table might be in any order. So you could actually have something like YZX in here. And if you iterate all children in a compound, you do have a method for that. You can go child, you can go num childs, I think it is, yeah, num children. This will tell you the number of children that you actually have on a compound. But if you iterate by that with child 0, child 1, child 2, you might be retrieving something that is in this order and form a vector from it. So, you know, you will want your m float vector. And you trust the order of retrieval, which is going to be like this. And there is no guarantee whatsoever that items are going to be in the right order. And madness will ensue because you just built yourself a vector out of these expecting XYZ, and you got YZX. So hopefully that makes sense. And the thing that when you deal with vectors like XYZ being reversed into YZX and stuff like that, it will still be the same length of vector. It will still, because you're still building a triangle with the same squares, it will be deceivingly similar to what you thought you were getting, but you were not getting that. So either you know the number of the names of the parameters and you explicitly look at those, or you have to look and order by name. And I will say, let us do that real quick. So if this sounds complicated, it in a way kind of is, but it's the nature of like dealing with data in its raw form, which is what a lot of OM2 stuff does. You get speed and you get not quite parity, but you get very close to synchronicity with the C++ API. But you have to know what you're doing. You're putting your hands in Maya's guts here. You're not using Pymo or something else that wraps things nicely for you. So endpoint from plug. We have a plug and we are saying it's a compound. So let's say if not plug is compound, and that will probably be an attribute or not plug. Sorry for that. Or not plug dot num children, we said it was, or children count. What was it? Num children. Not plug num children. That's probably a method. Yep. Then in that case we return none. So we want to first validate that we are doing the right thing here. So if I was to give it a plug that is, let's say, blended rot, where is it? Let's print something. I definitely not gonna make it to the callback, damn it. Print that and return, otherwise print plug. Sure, we'll do that. So if I was to do something like that and get, let's say, the blended rotation, I should get, okay, endpoint from plug, blended rotation. Oh, you know what? No, because that's a straight up angle. So are we doing the right thing? Endpoint from plug. Let me also, while you write your prototypes or functions before you're sure of what you're doing, you know, if you put them closer to where you're working, you're gonna have an easier life. You won't need to line jump as much as we're doing. So if not plug is compound should be a property, I believe, but I'm not 100% sure. Let's check. Yeah, it's a property. So if not plug is compound or not plug num children equals 2. So this is gonna, like, if this wasn't a compound plug, this would error, but because we're checking for that first, it should be okay. Let's make sure we're calling it. Oh, we have, there you go. Unexpected internal failure, that's okay. We can deal with that. Endpoint from plug, blend rotation, that's a string, so yeah, I don't know what I was thinking there. What you want is the value that we have in here, getting closer. Attributes get blended rotation, runtime error, and expected failure. Is that the one from before? Let's clear the log. So you might be hearing screaming in the background. My daughter has woken up. So line 33, so that's where? Matrix from plug. Oh, we're erroring the matrix from plug. So let's comment those out for a second. Attribute error 68. Mplug as no attribute is compound. There you go. There's a typo in there. So yep, not a compound. But if I was instead to ask for IK pedal offset, spell compound. Yeah, somebody in chat. I did. If I was to get IK pedal offset, I should, in theory, print the plug, but I am not. I suspect that I'm not even calling the right thing or something like that. What am I doing here? I am doing something stupid. Attributes get, okay. Ah, of course. Yeah, now it makes sense. I had the wrong object selected. We made things a little bit too safe for us. It would be slow to have a debugger to use right now. Yeah, the whole debugging thing. If Python was easier to attach a debugger to from inside Maya, that would be nice. You can actually get the stuff going relatively easily with an IDE and hooking it up and all of that. Python debugger is not bad at all, to be honest. Anyway, so in here, do we have the right plug? So we're printing blah, but not the plug. What the hell is going on? Oh no, we are. AK pedal offset. So we okay, that's fair enough. So we are not getting the source plug. That makes perfect sense. What we want to get is the source of that. And this is gonna be something that we need to do. So this is also wrong. Matrix from plug, and so we're looking at the plug here, which is always message, and that's why nothing is working in those regards. So we want to look at the source, which should be easy to fix. Now, when we receive a plug, where is it? Matrix from plug, we want to go and get the source. So instead of the plug, as in the plug that we want to extract the matrix for, we need to look up the source plug. So do we want to give it the source plug? Yeah, sure, we're doing prototypey stuff. So if plug is destination, it means that plug is connected. Property, again in C++, you'll find is your method. Then you can go matrix plug equals, and you might want more checks than these. Source, and at that point this becomes matrix plug, and I think we are good with this. Otherwise we return, let's do none. Now for this one we want to go if plug, same thing. If plug is destination, and we want to get the source plug. The other one I call matrix plug, and it will error if it's not a matrix plug, but at this point we gotta move on, so we're gonna be a bit sketchy here. So we're gonna go plug.source, and we can go and change these to source plug, and this to source plug. So in this case, we want to go and say no, no good. Otherwise, let's say that we return the source plug. Well, we print the source plug. We're just validating. So what are we doing wrong and where? I really want to get rid of this stuff. There's more crowd than there needs to be. We are, we are calling what we expect to be calling, matrix from plug. IK pedal offset is the only one, endpoint from plug. We're getting IK pedal offset, so that's fine. It feels like I'm not calling something, or I'm not initial. Oh yes, stupid. I keep resetting the selection. So we are getting to translate. That keeps, like, being so safe is constantly biting me in the ass right now. So we're good. We're good all along after the last couple of changes. Now the next thing we want to do is, if this is not true, then we will return none. But if it is true, it means that we are here, and this is what we want. That return none is an early exit. Python always returns none if you don't specify a return. So source plug is fine. Then you need to look for the children and verify that the children name is what you expect. So for I in X range, what is it? Source plug, we say none children. Print should be source plug child the number. So that should do us, and it's translate X, translate Y, translate Z. So if we want to find just the name, it will probably give us the full name. So there is a convenient method here, which I forget the name of right now. Partial name. Because you can get the name, but that gets you the full length of basically the path to that plug, including the object. I don't want to use ends with if I can avoid it. Oh man, partial name. So partial name is actually super useful because unlike name, it takes some parameters, and you can tell it, you know, not to use the alias, not to use the full attribute path, and so on. So we are interested in use alias and include node name in not having them. So what we want to give it is partial name, and we want to go include alias equals false, and the other one we're interested in is use alias equal false. If you're doing names and you're like being this specific, invalid keyword for this function, did I use alias, not include alias? Use alias. That's what I'm stupid. I am just plain stupid. So if you're doing something like this name specific, I find that not using the alias and not including a node name and so on, like be specific about what you do. So what we want here, we're almost there finally. In this case is we want an endpoint. Definitely not gonna make it to the callback, but hopefully this is interesting for you guys. An endpoint is not highly volatile. Like if you return it, it's gonna be safe and sound when it reaches the destination. Then what we want to do is, I mean, there will be more elegant ways to do this, but what we want to do is mp.x and mp.y and mp.z. So okay, let's do something. Real name of the plug equals that. So if real names equals tx, okay, elif real name equals dy, sure, miss shortcut. Now then what we want to do is mp.x equals source plug.child.y. This should be coming in as a float just fine. I would expect it to. Copy and paste that, be careful with it. So I would expect this to work, to be honest, unless we make more stupid mistakes, but print mp. So there you go. We actually got the values that we wanted, which should be the offsets that we have on that. And here's the important bit, and here's why I'm using an endpoint, because we're going to multiply by a matrix. And I think I touched on this, so this is just going to be a reminder. If you have a 4x4 matrix, and that is your transform, I am really struggling with this. and that is your transform. Remember what we said, that this is like the default for the AD matrix is going to be like that. If you want the translation, difference between free vector like this, where implied there is a 0, or, and this is going to be what float vectors or the normal m vectors are going to get you. And the difference between a point, which Maya specifies as endpoint, is that this is A, this is not implied anymore. You have a W parameter, and even if it was implied, it's implied as a 1. Now, without that one, whenever you multiply this displacement, and we're talking of the displacement from the staves to the pedal, So we are actually interested in this as a displacement between the 2 points. If you did not have this one, it will be considered just a rotation, so just the orientation of that vector, and you will not get this offset. You will get this direction, and the magnitude of the vector when it comes to displacing the point will be here. So that's why you use an endpoint. So if you multiply a vector by a matrix in Maya, they do the mathematically correct thing, and they will not consider displacement. So use endpoints, or implement your own multiplications if you want to use sparser types. Now, I can't believe how late we are in this yet again, but hopefully this is, it's more on 2, I guess, in a way, or more programming, but hopefully this is still useful. Now, we are sort of happy with this, so time to move it back to where it belongs. Whoa, too much love. And so we have war matrix from node, matrix from plug, endpoint from plug. So we should call these from plug source and that one from plug source. Might seem pedantic, but it's the kind of stuff that will eventually come back to bite you. Alright. So we made it this far. Now, if it's valid, you have all of these. So let's try and print it. So that should be the blended rotation. That's not going to be a rotation yet. It's going to be the just the angle for it. No, we want IK pedal offset here. So we seem in good condition. We seem to have everything we need. So at least the fetching part of things is good. Hopefully this is not putting people off writing OM2 or callbacks or stuff like that, making it feel like an overly lengthy process. Like having to talk about it and explain everything makes it take considerably more time than it would actually take me to write the thing for real. We have all the stuff we want. So what we want out of that is an actual blended rotation for this one, which we did show here. The angle does come in as radians right away. We have verified that, so we will use the short form for it. Now, are we doing something with the rotorder? Yeah, we're passing a rotorder. Let's assume one, because no, let's not assume things. Assume makes an ass of you and me, as they say. So what we want is we want to steal that line, and we want to steal that. And we can straight up replace this. Hopefully I've sold some charcoal licenses for Chris at this point. And that's the value that we actually want to get. If people have edited with the default my editor and have seen how this works, I mean, sure, it's not like using PyCharm, but I think it goes a very long way towards being better than the factory one. Autodesk, if you're listening, this might actually be one plugin worth buying. And we are good with these. So let's also make sure that we're right. Value error, no matching constructor found. So I bet you that this takes a float. What will we get if I use as double? 000 KYs. So that should get the M angle, and then as radians like that. I think it's what we're doing. Yeah, angle as radians. Yeah, these being Python. So if you get it as double, I think you get the actual radians as double right away. So that would be a shortcut. Otherwise, if you want to make triple, sure, get it as an M angle, and then uses radians inlined. So blender rotation is like that, and we were looking at that. So the part I'm curious about here is I would not expect these to be a 0. That part I don't like. So I want to make sure that I'm not doing something stupid. Well, there's also a syntax error here somewhere. Print attributes gap blender rotation as M angle as radians. We should actually be able to do this. So this keeps biting me so hard. So the blender rotation as M angle as radians here, I would have expected it to have some values, to be honest, because it's coming in as 55 and 49, it's weighted, so I would expect it to be radians equivalent of 55. Either we are storing something stupid, or oh yes, because I'm getting the plug and not the source. There you go. This might be getting a bit long for a single call, but let's assume it has a source. So attributes gap blender rotation source. Wow, it's getting long. Source is M angle as radians. Print. So let's try that just to, and let's get the right selection. There you go. That looks a lot better. So we now do have everything, I believe. We have the Euler rotation, we have the pedal offset, and we have the FK buffer matrix, and we have the IK buffer matrix and all that good stuff. Now, what do we do with all of these? We can probably, so we are in FK mode. We could probably actually build ourselves the transformation chain. Hour and 15, and I reckon we can do another 50 minutes if we get there, so at least we get the script version of these working one way, and then tomorrow we definitely finish these, and I think I've said it twice at this point, and twice I've gone off on tangents. Chat, yet again, you are my sounding board. Let me know how this is going, but I reckon we want another 50 minutes to make this work, and my hands are really cold. And I'm also wetting my face. All right. $15 or $50? 15, 1-5. Yeah, I don't think I can go for another 50 minutes. I've done 2 hours and 5 minutes stream, and yeah, nah, not this one. So I'm gonna push it for another 50 minutes or something like that, and do 10 minutes Q&A, and if there's no Q&A, we'll see where we are with the rest and then call it. Oh, actually, I'm already 1 hour and 50 minutes in. Well, started late. Anyway, let's move on. What I want to do is get these offset, then rotate it by this blender rotation for sure, then multiply it by whatever. That is good actually, because if I go that way and then I multiply by the buffer for the IK, I should have everything I need. Now I'm also tempted to actually go and do some of the stuff we say we would have done, because what I have here is a vector. So tempted to actually implement it raw. I have a vector that is, in respect to the staves, gonna be something like this, and the angle should always be 1D, and that means that you know, let's say it's this is clockwise for now, but let's say it's fine because it's just the angle between two items. So I will be able in theory to straight up just my original vector for the offset will be something like this, right? If I wanted it rotated, I wouldn't need to do all the matrix and rot and stuff like that. I could just get the y component of this vector multiplied by the cosine of that angle and get the y component of my new vector, multiply by get the length of that and do that operation, but you get what I'm saying. Yeah, and get the sine of it, and that will get me the x component and leave the z unaltered. While that is very tempting, I might not go through that right now. So, but you know, food for thought category, like if you want to do it proper in the script, like I reckon it's worth for you to go down and get your hands dirty and just get only the angle and multiply by that. Now we're also saying that in theory we might support this kind of arbitrary rotation, though we're not right now because we're going out with a straight angle. Up to you. Let us move on. We have all of that. Now what do I have for vectors and rotation? Do I have a vector in the Maya API, a vector by rotation? If anybody, so let's see if Euler rotation has anything useful in these regards. I don't think so, but if anybody knows off the top of their head in chat, please let me know. So this is all rotation centric, which is not unexpected. Does endpoint have a trend multiplied by rotation? So endpoint has rationalized, Cartesianized, rationalized, and so on. I might need to get myself a matrix to do the work. A little bit annoying, but not super terrible. So does a matrix multiply by rotation? No, it seems that I have to get myself a full transformation matrix. We were doing something like that already, so we can look at that. And it was, I believe, that's to get the matrix. I was doing a multiply somewhere before, which I might have erased. I think it's in the stuff that I erased in the end. So, but it should still be here. So I was showing transformation matrix from, you know, whatever matrix we're getting. Then I was setting the rotation by something. Now, if I get a matrix, I'm so torn right now. I actually want to do this properly. So, tell you what, blend the rotation, scrap that. We're gonna do it good and proper. Python, we do have the power. We do have sine and cosine. Now, blend the rotation. So what we want to get, we said, is we should have, and this is not going to work great for all angles, so we're not going to consider the quadrant just yet. We just want to see if we can make it that far. We say we have this offset vector. We ignore the z component. We take the y component of it. Let's make sure we're not making, like, doing something stupid here for a second. And might want to select this thing. So these, as it is now, has, oh, that's dangerous. So this has a strong x presence, which is the offset this way, and that makes sense. And strong x presence, which is the offset that way, and a strong, okay, sure. That docking, undocking, I should just turn it off when I do these things. And a strong y presence in negative, which is going to be this. So if I take that y, that is pretty much my length. So then multiply that by the, and the rotation should be, let's print that as well and make sure that we're not doing something stupid. .097 and so on and on. So let's actually do it as degrees to make sure we're not hallucinating. As degree or as degrees? We'll find out. Yeah, as degrees. So we have a minus 55. Seems correct. So we're going in that way. If I get the sign of minus, like the sign of 0 is going to be 0. So the y component in this case is pretty much my length, and the z component is what I want to augment. So this is pretty much the projected length, which is what I care about. The x component in this case I reckon I will be keeping as is. Sorry, the y component is the one I'm interested in. I don't want to confuse things, but I am. The x component I will keep, because we just want to stay at that distance. The y component is going to be my projected length, which I'm interested in. So let's see what we can get out of that. That would be like a pedal offset dot y print projected length. That should get me, yeah, we have the right selection. So I was saying the sine of my blender rotation by that length should be interesting. So sine of blender rotation by the projected length do I need to import math for that? I think I need to. Come on. So that's starting to look pretty interesting. Now, if the sine of that is going to reduce my projected length. So if I was at, I would expect this at 0. So rotate. And select the right item. Okay, so this is -0, which is cool. And I think we've had to negate that thing before. And at this point, I would expect some progress. I should probably just fetch this object by name and work on it. So 079. Now I bet you that if I put these at this number, that will get me somewhere. And in these objects coordinates space, that will be on the Z, I imagine. Yep. So I would, oh come on, pretty positive we will need to negate it. What am I doing here? Why is it hating me so much? I can't, for some reason I cannot paste in this field. Whatever. Why the hate? Paste. Damn it. There you go. So, okay, that seems legit. We seem to get the right Z coordinate out of it. Now, I would also expect that by getting the cosine of that, so that at the beginning it will be full length, because the cosine is going to be 1 here, and here it will be 0, I will get the y equivalent of that. So, what am I doing here? That's correct. And that's going to be my, we said, Z. And then I will want to get, sorry, I'm just trying to remap things in my head. Then I will want to get the y to be, is that negative? I need to look at the spaces for these, but let's start printing the values. I will want the cosine of that. And let's go and print Z and Y. After selecting the right objects, how many times have I made that mistake now? So, getting somewhere now, 0793, so we know that we want the Z to be there. Oh, this is buffered at that point. So what we want, because we've made the buffer of this thing here to be at 0. So if I zero out these, let's have a look. We end up there. Which means that my Z is useful right away, whereas my the offset here needs to be negative. So if I actually use the 1 minus to go subtractive on the cosine, I might get an interesting number after I select the object yet again. So this is going to be minus 0, 0, whatever. Might need to do by minus projected length, but what I'm doing there is, if this is the 0, what I'm interested in is as this rotates and the cosine produces this offset, and then as it rotates these ways it produces less and less offset and so on. What I actually want, in a way, it is the cosine, but it's the cosine of 1 minus, so that we are generating the cosine wave in this direction. This being positive in that case, and it's going to get interesting when we get to the other side, because instead of relying on the rotation alone, we'll need to go, okay, if we're in this quadrant, we actually need to add yet again after having added that offset. If it doesn't make sense, don't worry, we'll get to it. So what I'm interested in is a positive value, and this I reckon will get me a negative. If I selected it, sure, will get me a negative value. So 1 minus math cosine. Could probably invert the quadrant and see what happens, or I could just do that for the time being. Now the x positive is interesting, so that looks alright. I think we are onto something. We could actually implement all of these as nodes to see it happening live, but does this make sense, chat? I really need you on this, because I've jumped some hoops and I was indecisive about doing it properly with sine and cosine, and then I said, yeah, sure. It seems like the right thing to do, but what I'm getting out of these is basically, actually, let me just, because sometimes, parallel settings control, sometimes you just don't want to spend months fuzzing around with things. Okay, so is that working? I think so, but we're not printing anything yet. So something somewhere is going wrong, isn't it? Do we have okay, now it's fine. Is our selection thingy working here? Is it doing us any favors? It's selecting it but not setting it as the active selection or something like that. I probably have to turn it to highlight. Anyway, this works. So we do have what we want here. Oh, there, now I remember what I was doing. I was taking the buffer, so if I multiplied by the inverse of the buffer, I would have actually been good with these. But for the time being, like, let's not do that just yet. Let's actually test those values out. I think we are good in those regards, and I would expect to have these on the Z as we say we would have had, and these on the Y, and to work. And it will probably stop working in 2 out of 4 quadrants, but let's validate it. So at this point I would expect the, whoa, sure. I was saying I would expect these to be valid for the Z, and we should have much higher positive value in the Y. It's okay, our logic is good. We're getting what we want out of it, and we are 1.5 in, so I know I didn't get to the callback just yet, well, again, I should say, but we got it working in script form. Now, what we've basically done with this is done the the FK to IK part, which is, you know, the trickier of the two because you need to account for the offset and all of that. The FK to IK one is going to be trivial because you literally just need to grab this angle and put it in there. So if you want validation of that, you know, we can move this one here, switch it. So that doesn't really worry me as much. Normally going the other way around is more interesting. So if we were to look at this value, whatever that value is, blended rod, we have it. So and oops, okay, sure, 0.08. Let's actually print it as degrees. So it should be as simple as, oh come on, as getting that value and pretty much dumping it in here, and that's your IK to FK switch. So not much work to do in those regards. But the IK FK one, as in getting the IK in the position of the FK, that's the one where you have to account for the offsets and all of that, and the more interesting one to do, I guess. So 1.5 hours in, unless there are any questions, I reckon we are in, you know, in a decent enough place. I mean, this is not mind-blowing, but it's solid enough work. We have the entire logic of what we wanted to do, which is getting the various values, having all the connections, and doing row transforms instead of doing expensive matrix composition and operation. Just, you know, this is as simple as it is. I guess this is what I was harping on about. If you know just the most tiny basics of algebra and trigonometry, you very often can take raw values and make it work out of that. We're only printing stuff. It's not exciting. We're not connecting it yet, but I reckon that we're gonna make short work of that part in the next stream now that we have all the logic. Questions, dubs, comments, suggestions. Otherwise, I am gonna call it, and we'll do the actual callback implementation tomorrow, same place, same time. I hope oh man, did I remember to start the video? Yeah, I did remember to start the video recording. I think I had a small heart attack there for a moment. All right, the only comment I have in chat is that it's making sense to someone, which is great. We've done so much more scripting in the last few days, but I was really chomping at the bit to do some programming on stream. And, you know, hopefully you guys and girls got something out of it in terms of OM2 and looking at transforms and some of the Maya trickery to extract matrices and so on. I have to do some things, it's way beyond me. Yeah. It's actually, so here's the thing about programming in general. You should write code every day. Don't buy into the whole thing of like reading books and, you know, and following all these magic steps to this or that thing. If you want to learn to write code, write code. If you want to learn an API, write against that API. I know it sounds counterproductive, but bashing your head against walls is very often the only way to do it. Any exercise you can try for OpenMaya is kind of tough. It's like, so here's the problem, and this is one of the reasons why I'm doing this stream, that there's a lot of stuff like OM2 is so underutilized and so, because it only makes sense really if you know Maya enough and C++ enough. I'm finding it underrepresented and underestimated by people, which is very sad. For using it in terms of like, exercises to try for OpenMaya, I would say do the stupidest possible things, and this is how I've learned a lot of APIs, even if they seem pointless. And if you can do something, don't give up on it, but de-escalate things to the absolute minimum, the absolute minimum that you can think of. So to give you an example, like this is something that you could try, and a lot of it is reading documentation, and this is the problem I was talking about with the documentation the other day and why I'm doing streams and stuff like that. It's ironically great, or good at least, if you know what you're looking for. So it's real documentation of You know, it's like a dictionary. A dictionary isn't very good if you don't know the word you want to use. It's great if you want to know more about a word that you know of. Documentation is the same thing, but think of the simplest things you do in the interface, like, you know, what is this thing called? What is my selection? So if you use commands, and in terms of Python, I mean, you can just go, you know, from my oh, come on, off by one, terrible. You could do something, you know, print, what is it, commands dot less with nothing, I think will get to the current selection, and you will get a bunch of strings, right? So commands are like this comforting blanket of scripting where everything is immediate. But and in some cases they're actually pretty useful, to be honest. If I want the strings for everything selected, I will not just jump through hoops and do it in OM2. I will just ls, it's fine. But if you go, okay, what's the first thing that you need? It's usually knowing the selection so that you can actually work, so that you can look at things. And the first thing to do for something like that in OpenMaya, and bear in mind, if you're not on 2017, not on 2016, I'd say there's quite a few things missing. If you're on 2017, it's now got pretty decent completeness. Yeah, somebody was saying, yeah, that's true. Command ls SL equal true for the current selection. Command ls is all the nodes in the scene. Yeah. So the first thing you want to do is, okay, how does Maya think about the selection? And this is where, you know, documentation is not going to do you any favors, but you can read it page to page. I mean, I've done that actually, believe it or not. And mglobal, oh, actually, sorry, we're in Python land. So let's take out that stuff and let's search again. So mglobal is where Maya holds all of the global state kind of stuff. So any commands that are running to tell you if that command is redoing something or is undoing, or if you want to know what's selected and what the selection mode and so on. So the state of Maya in general is where a lot of that stuff ends up in mglobal. So if you were to go, okay, print OM2 mglobal, it's just going to give you the module, right? If you want to know everything that is in it, if you don't want to look at the doco, and sometimes the doco doesn't contain everything, you can always print the directory of what's in it, and that's going to tell you everything you can, well, mostly everything that you can do with mglobal. And you will find things like set enemy selection mask, set active selection list, and so on. Compared to the C++ one, it's missing the highlight stuff, so you can actually set selections that will not be highlighted in Maya. So you will set a selection that is active and all, but this is not going to happen, the highlighting part. Be aware of that. But so if you wanted to get something, you will go, okay, om2.mglobal is going to be my global state, and in there you have something called get active selection list. And what do you get out of it? So it's a lot of exploration basically, and then you can go, okay, print, you know, the type of that something, and you will get it's an OpenMyM selection list. So cool, move one up. You know, you've moved it as far down as you can by looking at it global. Now you've moved one up back. You go, okay, I got something out of it. What does mSelection list have for me? And mSelection list has a bunch of things, and it will get you a dependency node, it will get you a plug, it gets you selection strings, and so on, right? And you will find, and this is where it gets a little bit tricky, that it has init and string. Init is how Python initializes objects. Python is Python, like you can learn it. There's a ton of material out there for it. String means that you can actually return it as a string, and you can add things, and in there you'll find, okay, it takes some object, and backpath, and plug, and so on. And that's basically how you learn it, which is the really hard way. Hopefully we'll do, maybe there's good material out there, I don't know if maybe Rigging Dojo has some good courses on it. I'm not gonna mention names, but there are some very expensive workshops around that say they're gonna teach you Maya scripting, and they're actually horrifying. They're very amateurish, but at least the two people I know that do programming stuff for Rigging Dojo are very competent, so you can trust them. Trying to think if there's anything else. That's off the top of my head. I'm not sponsored or anything by any institution. So hopefully that is of some help. Look at examples. There's sadly not as many as you will find for PyML or something like that, but dissect the stuff I've been putting up on the stream. So look up the Docker for all of these, you know, and global, you'll find it's a global state of the scene, get at the selection list, you know, you go, okay, it means that, is that iterable? Can I iterate over something like that, over M selection list? So you try it, right? And you'll find that this is not iterable. And that is a Python thing. It does not have iter here. Whereas if you were to go into, what is it, mplug array, I believe is iterable. So in here, you will find that it actually has len and set slice and get slice and so on, which indicates that it behaves like a list. So if I had an mplug array, I knew I could do something like, and I think I've done it somewhere else at some point, you know, for each plug in my mplug array, or I could do things like, you know, my mplug array and take a slice of it. So only some items like that. It's very exploration driven and it will be some pain for a little bit, but it's worth doing. That's a pretty long answer, I guess, to what is essentially a simple question. But yeah, there's amazing Python material. Actually, oh, anybody in chat, I forget the name. I don't know why. His first name is Robert and he's left CG somewhat recently. Was the guy behind? I think it was Robert. Yeah, the guy behind technicalartist.org or technicalartist.com. What's his name? Somebody help me. He's written a pretty good Python for Maya book. I think there's a lot of PyML in there, but the guy is definitely competent, and I think he also released it for free. And if that's not available anymore, yes, thank you, Rob Galanakis. I think he's left CG, and he's definitely left Tech Artist, I think. But his book is out there. Let me see if we can find it, actually. I actually bought that book some time ago, mostly purely to support the guy, because it's not exactly stuff I didn't know. But I ended up reading most of it anyway, because it was pretty good. So let's see, does he still have the book around? So this should be the guy, Rob G3D, I believe. And oops, practical Maya programming with Python. There you go. And he did it with Packet, and I know he had some trouble with it, but in the end it came out. So yeah, somebody got to the same link. So trial is $0. Look through the interwebs, because at some point he was giving it away for free. And all right, I will say, you know, that's probably a good place to start. And really, learning Python is actually a classic, and it's pretty good. Learning Python. Just make sure you get one for Python 2.7, because if they've updated it to Python 3, yeah, updated for free and 2.7, so this edition will be right. This is a pretty classic book, and Mark Lutz is like, it's solid. If you want to know just about Python, that takes a good path for explaining several things. So I will recommend those two books. All right, this is now 1 hour and 45 minutes, which is, you know, another monster stream, I guess, but at least we not crack the 2 hours this time around. Yeah, sure, I want to delete it. All right, not quite callbacks, but we got the script, so the next time we'll convert it to callbacks. I hope it's gonna take less than an hour the next time. All right. Cool. I'm gonna call it here. Despite being up against Spider-Man Homecoming, we actually had attendance, which is great. I don't think we quite cracked the 5 million views in one night, but attendance was pretty good. I'm happy about it. And thanks everybody. Same time, same place tomorrow if you are on the stream, and let's finish these all callbacks and OM2 kerfuffle. If you're on YouTube, you know, whenever you consume these, you might find that the next episode is already up. Thanks everybody again. See you soon.